Hello, this is Gian, and this is Surveying Fieldwork number 6, Trigonometric Leveling. So let's first discuss the definition of trigonometric leveling. Trigonometric leveling, it is a type of indirect leveling defined as determination of the differences in elevation from observed vertical angles in either horizontal or inclined distances. This type of leveling mostly measures the vertical measurements or remote points, and we use the concept of trigonometry to determine the vertical measurements. So let's now proceed to the materials needed for this surveying fieldwork. So the materials needed for our fieldwork are: first is the leveling rod, theodolite, range poles, a 50-meter steel tape, or the marking pins such as chalk or markers.
Number 1. Set up the theodolite at a convenient location and call it point A, where the leveling rod and the remote point are visible. Number 2. Using the telescope, take sight at the topmost remote point, then read the vertical angle and record as A on Table 5 Trigonometric Leveling. Number 3. Take another sight for the second trial, and this is done to determine the precision of the observations. Number 4. Calculate the mean of the two vertical angles or the angle of elevation, not the zenith angle, of the specified point from the first station. Number 5. Set the leveling staff or rod vertically near the base of the remote point and take the level foresight. For example, horizontal line or zero vertical angle on the rod to determine the height of the instrument.
Transfer the instrument level or theodolite towards the location of the remote point and designate it as Station B. Then measure its distance by taping from its initial position or Station A. Record this as distance AB. After centering the bubble of the instrument level, sight at the same topmost remote point cited before, twice using the telescope, and record as beta on Table 5 Trigonometric Leveling. After recording these two observations of vertical angle, calculate the mean. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. Analyze. See figure below. The right angles formed to determine the height of the remote point. This fieldwork will not consider the effects of combined correction of Earth's curvature and refraction. Determine the difference in elevation between two instrument setups. Difference in elevation is equal to h sub 1 minus h sub 2.
Consider triangle B prime EF, then solve for distance x using the tangent function. Tangent of beta angle is equals to h sub 1 minus h sub 2 over x. Then, determine the sum of distance AB and distance x for the analysis of the oblique triangle A prime FD. So the formula is A prime F is equals to AB plus x. Next is consider triangle A prime FD and use sine law to determine the distance FD. So derive the equation AB plus x over sine of beta angle minus alpha angle is equals to FD over sine of alpha angle. Finally, consider triangle FDG and determine the height of the remote point DG. So sine of beta angle is equals to capital H minus H sub 1 over FD.
For the solution, we have to perform first the things required in the table. To attain the mean vertical angle A, we simply add the trial 1 and trial 2 and divide it by 2. Therefore, by substituting the data, mean vertical angle A is equals to 33 degrees 49 minutes plus 33 degrees 51 minutes over 2. That yields on the answer 33 degrees 50 minutes. To perform and to get the mean vertical angle of B, it is the same as the solution of A. Simply add the trial 1 and trial 2, then divide it into 2. Therefore, by substituting the data, mean vertical angle B is equals to 37 degrees plus 38 degrees over 2. That yields on the answer 37 degrees 30 minutes. For the height of the instrument A, same as the previous solution, we just have to get the average of 2 trials. By substituting the obtained data, mean height of instrument A is equals to 1.50 plus 1.48 over 2. That yields on the answer 1.49 meter. Same as the other solutions, we just have to get the average of 2 trials to get the mean height of the instrument B. By substituting the obtained data, mean height of instrument B is equals to 1.19 plus 1.21 over 2. That yields on the answer 1.20 meter. Now, to obtain the difference in HI, we simply subtract H1 and H2. So by substitution, difference in HI is equals to 1.49 minus 1.20. That yields on the answer 0.29 meter. Now, to get the value of x, we need to perform the trigonometric function, specifically the tangent function. Therefore, tangent beta is equals to h1 minus h2 over x, and by substitution, x is equals to 0.29 over tangent 37 degrees 30 minutes. That yields on the answer 0.378 meter. Next, by solving the A prime F, and obviously A prime F is equals to AB plus X, and by substitution, A prime F is equals to 7.71 plus 0.378. That yields on the answer 8.088 meter or 8.09 meter. Using the law of sine by getting the FD, the formula will be AB plus X over sine beta minus alpha is equals to FD over sine alpha. And by substitution, 8.09 over sine 37 degrees 30 minutes minus 33 degrees 50 minutes is equals to FD over sine 33 degrees 50 minutes, which yields on the answer FD is equals to 70.43 meter or 70.4 meter. And lastly, to obtain DG, which obviously equal to H minus H1, we need to perform another trigonometric function, but this time it is a sine function. So for the formula, will be sine B is equals to H minus H1 over FD, and by substitution, sine 37 degrees 30 minutes is equals to H minus H1 over 70.43. Multiplying the 70.43 both sides will isolate the H minus H1, then turn into H minus H1 is equals to sine 37 degrees 30 minutes multiplied by 70.43, which yields on the answer 42.83 meter or 42.9 meter.